Okay, hello and welcome to lesson 7 of topic 28, inequalities. So last lesson, and please make sure you've done last lesson before you have a go at this one. Last lesson we looked at this kind of concept of factorising and sketching graphs when you've got quadratics. And we're just going to continue on with that a little bit and just extend the difficulty level in terms of how complex our quadratic is. So our title is something relatively similar to last time, but this time when we're talking about a is greater than 1. So what I mean by that is if you've got a quadratic like this, and if you were to think about the quadratic formula, which is where you've got the negative b plus or minus, square root of b squared, that whole formula, the way that we look at that formula is we say that a is 1, b is 5, c is 6. Now when you've got a quadratic like this, see here that a equals 3. And so we're going to be looking today at this sort of quadratic, okay, the ones where you've got a number in front of x squared, a coefficient of x squared greater than 1, okay? So this is the sort of thing we're looking at. And within your class, you may have been taught a slightly different method to this. You may have looked at the idea of inspection, of looking at that and understanding how to factorise it straight away. However, the vast majority of you have looked at the idea of multiplication first and then splitting the middle term. Okay, so I'm going to focus on that method and just try and help people to understand that way of doing it. So initially, in order to be able to factorise this, we need to multiply the a times the c first. So we're looking at things, we're multiplying 2 times 2 there to get a total of 4. So 2 times 2 is 4 there. I'm then looking for numbers that multiply to make 4 and add to make 5. So 2 times 2, 4 times 1. Well, 4 times 1 is what I'm looking for there because they multiply to make 4 and they add to make 5. Okay? I'll just re-emphasise where the 4 came from. It was from doing the 2 times 2. Okay, the a times the c there. Now, once you've identified these numbers, you need to split this middle term into those two terms. So we're looking at 2x squared here, and then it doesn't matter which way around you put these numbers, you will get the same answer eventually. But if we go 4x first and 1x, you can write 1x or you can just say x. And just a reminder about where those two numbers have come from, the 4 and the 1 there, they've come from here. And then we're looking to split this into 2. And we're looking to factorise these two parts into one bracket. So looking at this first half, thinking about things that are common between 2x squared and 4x, I can take 2 out of that expression. I can also take x out of that expression. And if I look here, 2x squared, if I was to divide that by 2x, I'd be left with x there. Okay, x times x is going to make the x squared. And then 4x divided by 2x would leave me with 2. And again, 2 times 2x, 4x there. Now with this particular term, there's actually nothing to factorise here. And when there is nothing to factorise, you need to think about the idea of factorising it with just 1. Okay? If there's nothing you can take out that's common, then you just use the number 1. So we're saying 1 here, and then x plus 2. And I can tell that I've got that right because the terms that I've got, the expressions that I've got in the bracket are the same as each other, okay? And that will always be the case. If it's not, you must have gone wrong somewhere, okay? So now I've got these two expressions to be the same. I take this term and this term here, and I write it as 2x plus 1. And then I take this common bracket and write it as x plus 2. Okay, and that's factorised, all right? So that's factorised down to there. Now, similar to the last lesson, we also need to look at solving this. So if we go here and say 2x plus 1 needs to be equal to 0, rather than just try and swap the signs this time, you might need to write this out a little bit further. So move the 1, gets you 2x, everyone that's done that. Good. Let's try that again. So 2x equals negative 1, and then divide both sides by 2, so x equals negative a half. Now you can write that as a decimal if you want, but I think I prefer it as a fraction for the moment. This one is the more straightforward kind of bracket, so x plus 2 equals 0, x equals negative 2. So now, again, very similar to the last lesson in as much as now we've got our solutions, we need to sketch it. We're looking for x is negative 2 and x is negative 1/2. And then based on the fact that our quadratic is a parabola, we again are looking for a quadratic like that, okay? And again, similar to the previous lesson, yes, there are other things that we could put on this sketch, like a y-intercept and a minimum point, but we don't need to for this topic at this stage. So we're just going to focus on these x-intercepts here, which are these two solutions. Okay, so I'd like you to copy that down, and then I'm going to do 2 more examples. You don't necessarily need to copy the next 2 down, but I think it'd be important to listen and to understand, and maybe try them before I go through them if you wanted to. So the next one is this, relatively similar in its construction. You've got 2x squared, 11x and 12. First thing we're looking to do is the a times c, which is going to be the 2 times the 12 here, which is 24. So I'm now looking for 2 numbers that times to make 24 and add to make 11. So I can go through that process and I can try and figure out what those numbers are. You could write a couple of pairs down if you want, but we should be looking at 8 and 3 there. Now, when I split this middle term into the 8 and 3, as I said to you before, it doesn't matter the order in which you do that, but for me, I'm thinking about, if I've got 2x squared here, I know my factorising initially is going to involve 2, the number 2. So if I'm debating whether to put 3x and 8x, or to swap those round and do 8x and 3x, well, I'm probably going to go with the 8x just because I know that I can factorise it with 2, and that just feels like it's going to be slightly easier to me. It doesn't matter, you will get the same answer, but to me that's the order I'd do those 2 terms in. So I'm splitting the 11 into the 8 and 3 because of these 2 numbers, and then writing the 12 at the end as well. Split that in 2. So we're looking at what is common here. So I've got 2 and I've got x. Then divide that, leaves me with x here, and I need 4 there. So 4 times the 2x makes the 8x. We're then looking at factorising this side. Now in the previous example we had to take 1 out, but here we can see a commonality here, a common factor of 3. And again, x plus 4. And I can see that those 2 brackets are the same, therefore again, I know that I've got that correct at that point. I'm taking this term and this term for my first bracket, and this common bracket for my second bracket. The order in which you write those is irrelevant, so you could have swapped that and that could be the other way around. So that's my factorising. My solving gives me 2x plus 3 equals 0. So 2x equals negative 3, x equals negative 3 over 2. Here I've got x equals negative 4. And so on my sketch, I've got negative 4. It's worth just thinking about what that number is, because you need to think about which side of negative 4 does that go. Is it bigger than negative 4? Is it smaller than negative 4? And to do that, you can turn that into a decimal if you like, minus 1.5, or as a mixed fraction, minus 1.5. Either way, it's going to be here. Okay, so this side of negative 4, if that makes sense. And then again, we're looking at a quadratic, something like that. It doesn't matter for the purposes of this sketch whether your line here crosses the axis or not. In reality, it would. But again, we don't need to know what that number is at this stage for this topic. So I'll just look at one more. Let's look at that one actually. So let's look at this one. So we're looking at 9x squared minus 3x minus 20. Same concept, okay, so AC first. We're looking at AC equals 9 times negative 20 is negative 180. So we're looking for numbers that times to make negative 180 and that add to make negative 3. So the sum of them is negative 3. So we can go through those, but straight away, I think negative 15 times 12 is the pair that you're going to want. You could go through those combinations and have 18 and 10, 9 and 20, that sort of thing, 3 and 60. But 12 and 15 I think are going to be the numbers that work for this. Now 9x squared here, and again the order of this is irrelevant, whether you go negative 15 first or positive 12. It doesn't really matter. I think I'll probably go positive though first, and then I'll go negative 15x and negative 20. We're looking to split that. What's common here is 3, bracket 3, I need to put an x on the outside as well, sorry. So 3x there first of all. So 3 common in the 9 and the 12, x common in the x squared and x. Then I've got 3x there, 3 times 3 is the 9, x times x, x squared. And then 4 here, because 3x times 4 is 12x. Then in this particular expression, I'm looking to take out 5, or negative 5 rather. And I'm left with 3x here, and then positive 4. Now it's important just to get the signs right there, because I've got this negative 5 on the outside of my bracket here. Negative 5 times positive 4 is why you still get negative 20 there. Okay, so the signs do work for that because you've got the negative on the outside. And remember, I'm looking for the same expression in the bracket, so it should be the same there. Now, putting that together means I've got 3x minus 5 from the outside terms, and then 3x plus 4. Solutions to that. So 3x minus 5 equals 0. So 3x equals 5. X equals 5 over 3. With this one, 3x plus 4 equals 0. Moving the 4. And then dividing by the 3. And so finally, with my sketch, I've got negative 4 over 3. I've got 5 over 3. And it's just going to be a parabola that goes through those 2 points. So that's going to be your solution to that one. Now that's the last example there. Again, I would recommend getting that one down, especially because it is a little bit more complicated with the signs there. And the numbers are slightly bigger as well. Okay. So this is a really key, important concept, especially when you get to the idea of a coefficient of x squared greater than 1. People do find that quite difficult. So if you're finding that hard, that's fine. We're just going to need to practice that, okay? So have a go at the questions in the booklet and email your teachers if you've got any questions. All right, thank you.